All right, shall we start?
Yes, sir.
Okay, perfect. All right, welcome back everyone in this PCNSC course. So today we are starting our day one. I hope you guys have seen yesterday's lecture where we have, given some sort of demo of this PCNSC course, and I have introduced you everyone like how we will be proceeding in this particular lecture, right? So yesterday, some slides were left out, so I'll be starting from there. Okay. So a quick recap I'll be doing, and today I'll be more focusing on the functionality and the feature of Palo Alto. So as mentioned yesterday, that if you talk about the Palo Alto box, so this is the PA200, right? And this is a old model actually. Now we have PA220 over here. Okay. So basically today is lecture one. So we are starting our Palo Alto batch from here. All right. So what will be the approach? Like I'll be explaining the topic, right? And after that, I'll be asking you for your doubts. So what you can do, when I'll be explaining the concept or topic, what you can do, you can have a pen and paper. You can mention your doubts on a pen on a paper, and then when I'll ask you, like when I mention that, you can draft your doubts. You can ask your doubts, right? So this will be our approach for this particular course. So this is my introduction, which I have already given, that my name is Vikas and I'm working as a network security and compliance engineer from past 10 years approximately. And it's been 6 years I'm in the industry of teaching, where I'm giving trainings of multiple technologies like Checkpoint, Palo Alto, basically firewalls, proxies, and EPS and multiple technologies, right? So I'll be bundling all these experience of mine, and I'll be trying to train you in such a way that your upcoming interviews will be fruitful for everyone. All right. Okay. So the topic of the training we have already covered yesterday. We have given approximately 20 minutes on the topics. We have discussed a very detailed topic discussion we have done yesterday. So I don't think so today it's required. If you want to know that, anyone want to know that what all the topics we will be covering in this particular session or in this particular course, what you can do, you can go through the yesterday's lecture, and you'll be having the idea of this particular syllabus sort of thing. All right. So we'll be starting from here. Okay, like this will be the first slide I would like to discuss over here. So who all people are joined over here on this Zoom meeting? Anyone, like if anyone want to share, like what is your understanding about the firewall? What you understand? What is firewall? Tell me. Anyone, any small explanation, whatever you have in your mind.
Like firewall used to protect unauthorized access from internal and external.
Okay, correct.
So, sir, I basically think that it acts as a filter for a network architecture.
Okay. All right, correct. What else?
And also it allows the client or the customer to process any kind of any ingoing and outgoing packets as per their wish. Means this could be a lame answer, but it
Yeah,
should,
no issues, go on. It's layman. That's good. It's layman.
So I believe according to the general terms, it allows us or gives us the liberty to allow the ingoing and outgoing packets as per our wish, means as per our requirement.
Correct. Anyone else? Okay. All right. So let me give you the brief introduction about the firewall, how it came into the market, right? So what happens? This is my organization, right? Let's suppose this is networkings, right? This is my organization. This is the building of the organization, basically. And inside the building, we have different clusters, right? Where different users are sitting over there, correct? Now, with the building, I have a router over here. On the router, a link is connected. That link is coming from ISP, and from that link, I am connected with the internet, correct or not? But this is the basic fundamental of internet connectivity, right? Now, remember, like if you have completed your CCNA, I hope you guys have completed your CCNA, or at least basic N+ knowledge you guys have. So remember, when we used to study about the routers, inside the routers, we studied that we can create access list, ACLs, right? We can create access list, correct?
Yes, sir.
Right? Yes. So in that access list, what used to be there? What we used to do? We used to mention that network 192.168.1.0/24, destination will be internet, port will be 443, or for the internet we used to give 0.0.0.0 basically, right? Port 443, and the action will be allow, correct? This sort of access list we used to create on the router, right? Now, what has changed? On the router, we used to create this access list, right? We used to create multiple access lists, 10, 20, 30. But tell me one thing. Does a router is meant for ACLs? What is the core functionality of router? What you understand? What is the core functionality of a router?
It's
to different servers, or to different means outside the internet or within the intranet.
to use
General
different
use of the router. What you understand?
It uses the IP address.
Array routing,
It's
Baba.
It's
Routing.
routing the networks within
Right. Correct. So basic fundamental of router is to do the routing, right? What do you understand with routing? That the traffic is coming. Let me change my pen. That the one moment. That the traffic is coming from this cluster, and it will be coming to the router, and router will do what? It will forward accordingly to the another cluster, right or not? But traffic is coming from here, right? On this interface of the router. Router will check its routing table, and it will forward that traffic to this interface. That's what the router do, right? That's what you understood, and that's what you learned in the CCNA. What is the basic fundamental of router, right? That's why we call it router, correct?
Yes.
Now, the moment we started mentioning the ACL, we started creating the ACLs on the router, although it was not the basic functionality of a router, but still it supported the ACL. It has given us another free hand, right? This router technology has given us another free hand where we can take help of the router, but to do basic ACL and basic filtration of the traffic, right? But what happens over the time? The number of ACLs has increased. The number has gone to 100, 200, 500 and 1000. The moment the number of ACLs has entered in these segment like 500,000, you know, in that case, what happens? The basic functionality of router started differing, means the routing gets slower. Why? Because a router, if you talk about the router is not having a dedicated memory, right? It's not having a dedicated memory. It's not having a dedicated CPU. It's not having a dedicated cache for the ACL. What it is doing? It is using the available CPU. It is using the available memory. It's using the available cache, which is designed to do the routing, but for doing the ACL, but for doing the filtration. Okay. So initially the memory, the CPU, which was designed to do the routing, now it's doing the filtration also. So don't you think it's an additional load on the CPU? Don't you think it's an additional load on the memory? So the basic functionality of the router, which is routing, started delaying the services. So there we understood that we need to have a technology, we need to have some other device who can do only and only filtration. We will place that device before our router and it will filter the traffic, and router will get that traffic only which will be allowed by our filtration device. All right. Any doubt in till here? Anyone? Any small doubt?
So, so basically, if a route means firewall is placed in the network architecture, so ACL should not be created in routers, right?
No, it should not be there. If you have the firewall, there should not be any ACL on the router. Until or unless there is not a specific need for that. When we'll discuss the designing, no, I'll tell you what will be the need of ACL to be on the router. But logically, it should not be there. Okay.
Yeah.
So the need of a separate device has occurred, right? And the technicians, the scientists has developed one altogether a new device, and they name it a firewall. What they name it? A firewall. Now, what does the firewall do? Firewall does the same filtration which we were expecting from a router. All right. Now, if you understood till here, now let me come to the firewall. Now, when the firewall has came into the picture, its functionality was to filter the packet on the basis of source IP, destination IP, source port, destination port, and the direction. Right? Now, what do you understand with direction? Let's suppose this is my firewall. Right? Let's suppose, so in all this our classes, like in this particular course, whenever I'll be mentioning this sort of diagram, the left side always will be LAN side and the right side always will be WAN side. Is it clear? So this is my firewall, right? And the left side is my LAN side, right side is my WAN side. Here my internet is connected, correct? Now, what do you mean? Like, what do I mean with this direction option? See, when the traffic, let's suppose there is a person sitting and his name is Ajay. We do have Ajay with us, right? So Ajay is sitting over there in the LAN and he want to access one server on the internet. And this server is called google.com, right? So when Ajay will initiate the traffic for this google.com, this will be called what? This will be called outgoing traffic. What it is? Outgoing traffic, right? Or outside traffic. right? Multiple names are there. Whatever you feel comfortable, you can take it. Or you can say outbound traffic. Okay. Now, when Ajay initiated the traffic, it will be outbound. So in like, let's suppose the source IP is 192.168.1.124. Destination is 8.8.8.8. Source port, take any random port. Let's take 10110. Destination port, let's suppose 443. Direction, it will be outbound or outside. Okay, whatever you name it, you just name it. This, on the basis of this particular information, this firewall used to filter the traffic. Correct? Now, when this google.com will send the packet back to Ajay, this traffic has to go with the firewall, right? So what was the scenario? We has to configure the bidirectional policy in that case, that see, when Ajay is going outside, I have one policy, but when the server, when the google.com will be coming back to Ajay, there has to be one policy, right? So we used to create one more rule over here. The source will be 8.8.8.8. Destination will be 192.168.1.11. Sorry, 124. Source port will be 443, destination will be 10110, and it will be inbound this time, or incoming traffic, whatever you want to name it, right? So this sort of two rules we used to create in traditional firewalls. And if you have worked with ASA, you will relate with my statement. You will understand that we needed to create two rules basically. Whenever it was mentioned that we need, sometimes you may get that I need bidirectional policy for this particular communication, right? So this is how the traditional firewall used to work. Correct? So do you understood what is firewall, how it works? Any doubt? Anyone?
Sir, for that next generation firewall right now, we don't need any bidirectional.
We are
policy,
not
right?
coming to the, we are not discussing the next generation firewall. We are just discussing the firewall right now. Only traditional firewall. Simple term.
Okay.
Will come on the next generation firewall after this. Yeah.
Okay, sir.
Everyone understood the firewall, right? See, I'm starting from very basic, right? What my understanding is, you all are on the 0th level, right? So I'll be dragging you all guys from 0th level to the 100th level. This is my task. That's why like networking has given me this badge, right? All right. So you understood the firewall, right? Now let's come to this definition. What it says: one enhanced technology to protect our network, right? So if you take this definition till here, if you take definition till here, what we are talking about? We are talking about the firewall. Simple. We developed a firewall after router, right? So it is what? It is enhanced technology, right? Because ACL router can also do, but router is not designed for that particular task. So what we have done, we have came up with a new solution, and that is firewall. So one enhanced technology to protect our network. And how it will protect? On the basis of 6-tuple information, right? What is 6-tuple? Source IP, destination IP, source port, destination port, or direction. Correct? Sometime in your interview, the person may ask, what is 6-tuple? What do you understand with 6-tuple information? So that time you have to mention that source IP, destination IP, direction, port number, and all things, right? So on the basis of 6-tuple, my firewall, the enhanced technology, will protect my network, right? So till here, it's sorted. But the moment I'll increase this definition from unwanted viruses and the malwares. Now, how it does that? The moment I'll increase this definition, now we are not talking about firewall. Now we are talking about next generation firewall. Okay, so see, when firewall came into the market, over the time there were multiple technologies which were invented. If you talk about what used to be there, let's suppose this is my ISP router. From here I have connected with the internet. So before this router, I used to have what? I used to have a firewall, right? Now before this firewall, I used to have what? IDS. Before this, what I used to have what? IPS. Before this, I used to have what? DLP and XYZ solution, right? So if the user is sitting over here, what he has to do, he has to go to its switch. After the switch, it will go to Z and the X, then DLP, then IPS, then IDS, then firewall, then router, and then network. So these many hopes the traffic has to travel to reach the internet. Now, can you understand what sort of slowness this user may get? If it has to pass all these hurdles? You know, if you talk the era of 2000, right? From 2000 to 2005, 2006, I can recall administrators used to feel proud when their network used to have, like when they used to have slowness in their network. Why? They say that we do have these many security appliances in my network, so traffic has to be slow. If the slowness is there, that means it's good. That's what the mentality of the administrators over the time, at that time. But when this firewall has evolved itself, when apart from the firewall, next generation firewall has came into the market. Now this next generation firewall is having the functionality of IDS, IPS, DLP, X, Y, Z, everything this next generation firewall is having. Now what you have to do, you have to just replace, this is your user, you have to just replace all this bucket you are using. Here you have to use only one single technology, which is what? Which is your next generation firewall. Next generation firewall. So the traffic will be landed to your switch, from the switch to the firewall, from the firewall to the router, and to the router on the internet. That's all you have to do, right? Now, when we talk about, see, this X, right? This IPS, IDS, DLP I have mentioned, right? This X, you can keep it antivirus over here. You can, this Z, you can name it anti-spyware, right? So what will happen? Because all these functionalities are there on my next generation firewall. So what my firewall is capable of? It is capable to protect my network, as well as it is capable to protect my network from unwanted viruses, as well as the malware. Now my firewall is capable to prevent the DOS attack. What is DOS attack? Distributed denial of service. Denial of service. DDoS is distributed denial of service actually. DOS is denial of service basically. So now my firewall is evolving itself, and now my firewall is capable to handle the DOS attack even. It's capable to handle the viruses, malware, unwanted accesses, unwanted application, unwanted, category of the URL, right? Multiple things my firewall can do. Now, whatever technology you name it, whether it's a URL filtering, antivirus, right? We have mentioned antivirus, anti-spyware. You can have one more technology over here, which is called URL filtering, right? So can you see how many hopes are there in the traditional network? Now all these hopes has been removed, and now I have only one hope, which is next generation firewall. And this next generation firewall is having all the functionality. Believe me, We'll discuss all this functionality with respect to Palo Alto in our classes. When we'll discuss the profiles, right? In profiles, we'll see how you can configure the antivirus profile, URL filtering profiles, anti-spyware profile, IPS IDS profile. All these things we'll be discussing our classes, right? So I hope this first statement is clear to everyone. Anyone, any doubt? No doubt? Perfect. See, guys, if you'll not be saying anything, if there will be silence, right? So I'll understand that there is no doubt. Okay, that's what I presume actually. So if you have any doubt, anything, any smallest thing in your mind, let's just spit it out. Okay. Now the second definition, if you understood this one, no, this will become very easy for you. A technology through which we can provide advanced security in our organization. Now, what do you mean by advanced security? If I talk about the DLP, this is what? This is advanced security. If I talk about what? Your URL filtering, this is what? Advanced security. If you talk about the application identification, this is what? This is advanced security. So we are talking about the next generation firewall. So we can conclude here that if you are working with the next generation firewall, we can provide advanced security in our organization. We can provide totally a new solution to our organization. We can do the filtration of the traffic on a certain level that it will be very advanced security to our network. Okay, I hope this thing is clear to everyone. Any doubt? Now I hope you guys can explain what is a firewall, right? I think you guys have the understanding where to start and where to finish. Clear or not? Anyone?
Yes, sir.
Clear, sir.
Clear, right?
Yeah.
Okay. So if this is clear, then let's move further. So this is general term. This is general. We have not talked about the Palo Alto. We have not talked about the anything right now. We have just discussed the firewall, right? So let me repeat one more thing again, that this is the Gartner's report where Palo Alto is in the leaders. They are leaders in the market. Okay. And apart from this, if you ask me the certification path of the Palo Alto, so first it's PCCET, then PCNSA, and then PCNSE, right? So we are targeting over here, right? So what you can do after this training, you have to just take some experience. You can study the administration guide of the PCNSE for the current version which is going on, and you can go for your PCNSA exam. It will be very easy for you. Okay. Now let me proceed further, and let me come to directly here. Okay. So this particular diagram we have discussed yesterday, but it was a very quick discussion. Okay. Now what we'll do the detailed discussion in today's lecture, right? What is there? So Palo Alto architecture and the models. In 2005 they have developed this Palo Alto. Okay, one more thing. Do you know what is Palo Alto? Palo Alto is the name of a city basically. And there is a theory, I'm not sure whether that theory is correct or not. When this person, when this person used to, he's the founder and CEO of the, this Palo Alto firewall. So when there is a theory basically, there is a saying that when they were, developing that product, so they thought we have to have a company or through which we can register this product, right? So they were searching the name of the company, what should be the name. But in California, when they were sitting in their office, and that office was located in a city named Palo Alto. So if you search on the internet, Palo Alto, California, there is a city name called Palo Alto. So what they say that, okay, we are sitting in the Palo Alto city. So let's do one thing, name it Palo Alto Network, and later on we'll change the name. For right now, just take this name, and from there, this name is going on, right? So I hope this was very interesting, finding actually, theory actually. So I thought to share with you. So now you understood the Palo Alto, right? Like why they have named their technology as a Palo Alto. Now architecture. So in 2005 approximately, they have come up with this particular solution with this particular architecture and everything, and from there this solution, this architecture has boomed the market actually. Right now, what is the reason behind it? The reason behind it, the architecture of the Palo Alto, the model of the Palo Alto. Right now, if you ask me about the architecture, their architecture says SP3 architecture. What do you mean by SP3? Single pass parallel processing hardware. Okay, if you ask me, single pass parallel processing hardware, they have named it. Right now, when they have named it and when they have explained the concept to to the users or administrators or CTOs in the market, when they have shown you the product working on this particular phenomena, everyone was amazed. Why? Let me show you. What they said, that our architecture will use two things. First thing will be stateful inspection. Second thing is SP3 architecture. We'll come to the stateful inspection in some time. Although we have already discussed this stateful inspection in yesterday's class, but not an issue. We are considering today is the first class, so we'll discuss this thing again. Let's discuss the SP3 architecture. What it says. SP3 architecture says that single pass. Now, what do you understand with the single pass? Single pass says that let's suppose I have a firewall. I have a multiple module layer, right? Right. So let's suppose this is what? Antivirus, anti-spyware, malware, URL, file blocking, and anything XYZ, right? These are all the features of the Palo Alto, right? So what do you mean by single pass? Single pass says the packet will be coming. The packet will be coming like this, and it will be sent out. One moment. It will be sent out to all these functionality to do the analysis all together. How? The packet will go to antivirus. Antivirus will give its prediction. It will go to spyware. It will give the prediction. It will go to malware. It will give the prediction. It will go to URL. It will give the prediction. It will go to file blocking. It will give its prediction. By what? Like, what do you mean by prediction? Prediction means the answer whether this traffic should be allowed or not, like their analysis basically. So this packet is coming once inside the firewall and it is being evaluated by all these functionalities. This is called what? Single pass. The packet is coming once and being evaluated by all the functionality available inside the firewall. It has not to go one by one to all the functionality like the UTM actually. The packet will remain inside the firewall and it will be evaluated one by one by all the functionality available inside the Palo Alto or the firewall. This is called what? Single pass. Okay, so that's what this diagram says. Sorry, that's what this diagram says, that the traffic when will be coming to the firewall, it will go to the application ID, user ID, and content ID and everything in single pass software. All right. Now, this was the single pass. Now, what is parallel processing? Parallel processing says that in my hard, inside my firewall, I'll be having two planes. First plane called control plane, second plane called data plane. Now, what is the difference? So whenever you talk about doing configuration, if you want to do configuration, whenever you talk about logging, whenever you talk about the reporting, or whatever you talk about the management solution, you know, any management solution, whether configuration, logging, or reporting, it will be done by your control plane, right? You can call it management plane also, not a problem. But when you talk about data plane, all the security check, whether it's related to network security, it's related to security processing, it's related to signature matching, all these things will be done by your data plane. Okay, that's fine. We understood that this is control plane, this is data plane, they have separate functionality. That's good to understand. But the beautiful thing is, these all the processes, whether we talk about the network processing, security match, management, or control plane, they all are having dedicated CPU and RAM and SSD. So one like processing, like if you talk about the control plane is not relying on any of the CPU or the memory which is available on the data plane. And similarly, data plane is not relying on the memory and the CPU which is available for control plane. So inside one box, we have multiple CPU, we have multiple RAM, we have multiple SSD. My network processing is not relying on security processing for the CPU, RAM, and anything. My security processing is not relying on the security match, signature match, where we will check the antivirus, spyware, and the command and control. So all these functions, all these checks, all these features are having their own CPU, own dedicated RAM, and everything itself, right? Now, hope you understood this. So now, if you talk about the network processing, when we talk about the flow control, when we talk about the routing, ARP lookup, MAC lookup, quality of service, and the netting, these all operations will be done by network processor, and this all will be done by separate RAM and the. When we talk about the session lookup, the SSL, IPsec, decompression, these all things will be done by your security processor, and it's having its own RAM, it's having own CPU, right? It says this particular security processing will do what? Report and enforce the policy. Both the things will be done by this security processing. Now, if you talk about the exploits, when exploits means IPS, basically intrusion prevention system. When you talk about the IPS, when you talk about the viruses, spyware, command and control, for this thing, it's having a dedicated RAM, it's having a dedicated CPU. But it says single pass partition match. Okay. Now, if you want to understand network processing, it says front end network processing, hardware accelerated per packet, route lookup, MAC lookup, and NAT. So this network processing will doing this particular task. The security processing will do high density parallel processing for the flexibility, hardware acceleration for standardizing of the complex functions. Means this decompression, session setup. These are what? These are complex. Now, whenever you talk about the command and control and everything, it will be done by signature matching. And you understood the data and the control plane, right? And the beauty is, when the packet will be coming to this particular, firewall, this replica of the packet will be sent out to each of these planes, and all these planes will be processing the packet all together, and that is called what? Parallel processing, right? This is what? This is parallel processing. So I hope this architecture SP3, which is single pass parallel processing hardware, now you understood what is the functionality, why we call it SP3 basically over here.
Sir, I have one doubt. Sometimes I have seen that DP CPU is getting high utilized. So how that we can mitigate because of which issue it got high utilized
See, if
signature.
you data plane CPU is getting like highly utilized, then you have to check which model number you are using. If you are using 5500 series, it's a higher end model number. That means you will be having multiple CPUs over there inside the box. If you have one single CPU, then you have to check what all the operations you are performing from that CPU. So accordingly, you have to take the decision.
Sir, in coming days, can we show her some example of how that we can check
Not a
all
problem.
this?
Not a problem. Don't worry
Thank
about
you.
it.
Yeah, thank you, sir.
Right. So this is the basic understanding of this SP3 architecture. I hope you guys are comfortable. You guys have understood the SP3 architecture very well. Any single doubt you can draft right now.
Sir, second point you have said, right, for that SP3 architecture, it will send that first thing. It will send that packet has to be one-to-one. My kind of anti-spyware, UR filtering, flow control, everything it has to be travel. And second thing, it will duplicate the packet. It will send that to everyone. I mean, signature match, security processor, network processor, everything in a single stretch, right? That is the actual thing. The second point you tried to say, right? Okay.
Can you see this diagram? Even from the management, we are getting the packet on all the processors, no? Content, security, and the networking.
Okay, sir. But in control plane, management plane, there is a slight difference between control plane and management plane also, right, sir?
There has to be difference, right? Control plane is just to manage the device.
Okay.
And this data plane is to process the user traffic.
So, okay, once the packet has been originated from the LAN local network, it will send the packet within a single stretch to single signature match, security processor, network processor while creating a duplicate packet in a single pass to these features, right? Right, sir? Okay. First, before that, what you said, right? Before this, what you said, it has to travel one by one for URL filtering, MAC control, anti-spyware. What is that feature?
That is, see you. Oh, I have removed. See, that is what? That is, I'm talking about content engine. This is what content engine actually.
Okay.
So the traffic will be entering content engine once only, and it will be processed by all the next generation features, all the content inspection.
Okay.
That is single pass.
Okay. It is called as single pass, right?
Yes.
Okay.
Okay. Now, see, you understood till here, right?
Yeah, I know.
Yeah. So now, let's go back to. So this thing is clear. Now let me just give you understanding of the stateful inspection. So what happens if you talk about the traditional firewall? Okay, before the stateful inspection, let me come to this thing. Okay. All right. So, if you check, this is what? This is my Palo Alto 5000 series, and this is basic packet flow, right? So what happens is, let's take this diagram first of all, this one. Okay, the right side diagram. So we have a switch fabric. Now, what do you mean by switch fabric? Switch fabric is nothing, the number of ports, remember?
Yes, sir, physical port.
Yeah, physical port. That is called what? This is called switch fabric. So we have switch fabric over here. You can see the 20 Gbps quality of service engine will be here, and 80 Gbps switch fabric interconnect will be there. Means these ports will be capable of processing 80 Gbps traffic on this particular hardware. Okay, so we have a particular switch fabric. Now we have a control plane. What we have?
Control plane.
We have a control plane. Can you see how many cores are there?
4.
We have 4 core CPU for dedicated for this control plane, and we have multiple RAM and the SSD over here, right?
Yes.
And this is all together separate thing. This will be for quad core management, high speed logging, and the route update. Dual hard drives will be there so that you can do the management, right?
Yes.
Now let's come to the data part. Sorry, data plane, not data part, data plane.
Sir, I do have a question over here.
Yes, please.
Yeah, so regarding that switch fabric, can you please explain once more that part?
Switch fabric is nothing. You remember on the hardwares we used to have the ports.
Yes, yes.
That ports are called switch fabric. It's a term basically. It's a term.
Okay.
Remember in our laptops we have NIC card.
Yeah.
What is NIC card? NIC card is a LAN port,
Network,
right?
Yes, yeah.
So in Palo Alto, in hardware Palo Alto, we have the multiple ports, right?
Yeah.
So the combination of these, ports are called switch fabric.
Okay.
Okay, and switch fabric having 2 types of functionality. One is called it can process up to the 80 Gbps switch fabric internet capacity. Its capacity it will be having, and up to 20 Gbps of quality of service engine will be having behind this particular switch fabric.
Okay.
Sir, it's for single port or for whole?
For single port.
Okay. You mean suppose it's there in 8 ports, so.
Sir, you have mentioned something 80 Gbps of switch fabric. The speed has been conducted. What is the 20 Gbps engine means? It has
Quality of service. See, when let's suppose if the data traffic is coming to the firewall, right?
Okay.
So there will be some traffic. Let's suppose voice traffic.
Yes.
Right.
Yes.
So voice traffic will be what? Prioritized.
It has to be
It
prioritized.
can, what it can do, it can remove the 20 GB traffic, and it can prioritize.
You have to dedicatedly give the voice traffic to for.
Yes, so it can prioritize up to 20 GB of that traffic on the Palo Alto. So let's suppose if the 30 GB traffic has just landed to the Palo Alto, so it will not be able to process all the traffic in one go.
Okay.
It can process only 20 GB
So,
on one go, and then rest 10 GB will be another.
So from this picture, the traffic will be for QoS will be supported only 20 Gbps, right?
For this particular model.
Okay.
This is the hardware layout I'm telling you. Okay. Now we are running out of the time, so let us complete this particular diagram. You will be having very good understanding from this diagram. In the Palo Alto. Okay. So now let's come to data plane. In the data plane, you can see that. See, first what comes? Network processor, where 20 Gbps of front-end network processing will be done. Hardware acceleration per packet route lookup will be done. MAC address lookup and NAT and everything will be done, which is there. And the throughput for this network processor will be how much? 20 Gbps. Okay. Now after this, we have what? Security processor, where I'll be doing what? High density parallel processing for flexible security functionality. Right. So can you see after this particular data, see in the data plane, how many we have basically three in this data plane. We have 3 data planes actually. Logically, if you see with this diagram here, this is one data plane, but inside this one data plane, we have 3 data planes where this is my data plane number 1. Or you can say data plane 0. This is my data plane DP1, and this is my data plane DP2. 3 data planes I have. Can you see how many CPUs are there? 12 CPUs. 1, 2, 3, 4, and the 12 CPU means in one data plane I have 12 CPU, 2 RAMs, 1 SSL engine, 1 IPsec engine, 1 decompression engine. Similarly, I have 3 data planes. So what will happen? From the network processor, the traffic will be handed over to any of the data plane. either of the DP0, either of the DP1, either of the DP2. So in our lectures, I'll show you that through which data plane the traffic is getting passed, whether DP0, DP1, or DP2. So are you guys understanding that inside one data plane, I have multiple data planes, and my network processor will be handing over the traffic to the data planes. Now these data planes are having dedicatedly different engines, means they have the SSL engine over here. All these three means if the traffic will be landed to any of them, they have separate hardware for that. They can easily process that traffic. Then they do not require the intervention of any of other CPU, any of the other engine or anything.
So what
They have dedicated CPU, RAM, and everything.
What you're trying to say means it has 3 data planes. If the traffic originated from the LAN.
Wait a minute. Wait. Let me complete, please. Okay. So what is doing inside of one data plane? We have multiple data planes, right? DP1, DP0, DP1, DP2, right? So my network processor will hand over the traffic to any of the data plane, and it will be random. There is no phenomena for that it will do this and this first. No, it will be random. And now these data planes are self-sufficient to process the traffic. Now, after when these these data planes will be done with the processing, it will hand over the traffic to the signature matching hardware. Now, can you see? The RAM is there. Can you see how many numbers of RAM is there? For representation it is 4, but there will be maximum RAMs available in this signature matching. Why? Remember this diagram I have told you. This is what? This is signature match. This is the content actually. So here my packet will be remain for the longer period of time, right? Because let's suppose packet number A has entered and it is being processed till the time if the packet number B will come. So it has to be there in the RAM, right? So that my content engine can process that traffic, right? That's the reason I have multiple RAMs over here. I have to it has to hold the packet for a longer period of time in comparison to DP1 or network processor. Are you able to relate the things I'm telling you?
Yeah.
Right? Are you able to understand that network processor will do what?
Yes,
and when the data plane will process the traffic, how it can process the packet differently?
Yes.
Are you able to understand when my data plane will process the traffic, where it will hand over the traffic, and when the traffic will go to signature match, how it will process the traffic, and why it is having so many RAMs? Because it has to do signature matching. It has to check the IPS, IDs, and everything. So it has to keep the packet for longer period of time. So to keep the packet for longer period of time, we has to have what? Good amount of RAM. So that's the reason we are having these many number of RAMs. Now, if you want to see the packet flowing, can you see? This is my user. The traffic is coming to my switch fabric. From the switch fabric, it's going where? To the network. This is what? Network processor, where ARP and everything is going on, netting and everything. Flow control is being checked, right? And from the network processor, it is being handed over to DP1. Can you see it? They have mentioned DP0, DP1, DP2. Can you see here?
Yes, sir.
So this traffic has been handed over to DP1, and DP1 has handed over to this traffic to signature match. And from the signature match, it will come to your decompression and everything. From here, it will go back to your, your quality of service, and then it will be out. So, for right now, it's very broad overview I'm giving you. We will be able to understand this thing very, very, very clearly when I'll define this particular diagram to you. When I'll discuss in our Saturday's class, this particular diagram, this is what? This is packet flow of Palo Alto. So when we'll discuss the slow path, when we'll discuss this fast path, slow path, sorry, firewall slow path, this fast path and the application path, you will be able to connect the dots basically, which is there in your mind right now. So what I'm doing, let's suppose this is your mind. I am creating these dots. Over the time, these dots will be connected like this. Okay, so I hope I'm able to create these dots in your mind regarding the Palo Alto. Any doubt?
Yes.
Till here.
Sir, first you said it is a single pass communication. The second one features you said, right? What is the name called, sir?
What, sorry?
I mean, first you said the packet has to be traveled for every anti-spy URL putting. That is a name called single pass, right, sir? The second features you said, right? It has a dedicated engine for everything. What is the name called, sir?
Parallel processing.
Parallel processing. Okay. And one more thing, these features you have said, right, sir? It has a dedicated RAM for that control plane management. It is a default usage of Paloalto low end device to high end device.
No. If this is 5000 series model I am giving you, this is the hardware model of the 5000 series. This is the data center model.
Yeah, that is the actual thing. I just want to know the features. These features are, existing in from.
See, features will be there. The flow will be there like this. But there, the data plane, the number of, see, here we have 3 data planes.
Yes,
in
sir.
smaller model, you will be having 1 data plane only.
Yeah.
So the hardware will be only for 1 data plane. If you go for PA 220 or PA 800, there will be no hardware. Everything will be done by the software only.
Okay, everything not dedicatedly present in that firewall, right?
Yeah.
So what is the actual, these features has been comes from which model, sir?
From 3000 it started actually.
Okay. From 3000 only these features has been present, right, sir?
Yeah.
Okay. That's it.
Here. So this is the 5000 series I am telling you. Can you see how much big chassis is this? This is 6 feet 6 feet in the length actually. 6 feet lengthy chassis. This is 10 feet or something.
Okay. I think these things are used in data centers kind of.
These are the data center firewalls.
Okay.
So if you talk about the enterprise level firewalls, they start from here. So if you have very good organization, they will be using this firewall for your bigger sites, and then there will be 220 or many other firewalls out there. So this is the basic.
Basic model is 220 only, but yesterday you said there is a 200 model is the base model. But
I remember watch the recording again. I have mentioned 200 is the older model.
Yeah. That's what I'm saying. They have stopped, right? Okay. So 3000 models, these features has been present from that. Okay.
I have to download. Okay. Let me see if I can. Okay. Can you see the throughput of this particular firewall? For HTTP and HTTPS traffic, this PA 7000 model can generate up to 52 Gbps traffic.
Okay.
And if you talk about the DPCA model, it can generate up to 70 Gbps traffic. And if you talk about the 7080, it can generate up to 595 Gbps traffic. Threat prevention throughput, 292 Gbps of traffic. IPsec VPN throughput, 312 Gbps traffic. So the bigger the model will be, the better the latency will be, the better the throughput will be, right?
Okay.
Similarly, that's all. Yeah. So this is how what you can do. You can go just visit on this particular website, paloaltonetwork.com. Just try to have the understanding that what all the features, what all the, just try to understand what is the difference between the 400 series and 1400 series. Try to understand.
Okay.
Okay, try to understand what is the difference between the 3400 series and 3200 series. All right.
Okay, sir.
So yeah, that's all for today, I would say. And I think we have already completed our 1 hour, because today, like in these two sessions, we had